So this is the angle between them. This is R. This is F. The angle is this angle. So I have to go from R to where? To F. In which direction will be? This is this. This is this. So this was like this. From R to F positive. Now I will go from R. What is F? Here. And this is R. I go from R to F. Positive or negative? Negative torque. R to F. Negative torque. This is just to see the direction of torque. To get the magnitude, R, F, and the angle. You need to find the angle between them. Extending and putting tail with tail. Good. Knowing that, that is the torque. So, let me just give another example. Imagine that you have a pulley and you are pulling with the force F, the pulley. What is the torque? This is the pulley and this is your radius of the pulley. How can I find the torque on the pulley when you are pulling? You are pulling a pulley with a tension like this, like a yo-yo, an inverse yo-yo, like this. What will be the torque? By definition of torque, I will go tau equal to what? R. In this case, R coincides with the radius. Times what? The force F times sine of what angle? 90 degrees. How much we get for the torque? How much is sine of 90? 1. So we get RF. If the sine of the angle, if the angle is not 90 degrees, what will happen? If it's not 90 degrees, what will happen? If you apply the force not at 90 degrees, like this, and I apply the force like this, it will be torque greater or less? Less. So why most of the objects that we use to round, or to roll, are circular? Why? What is the reason that we use most of the objects to rotate circular objects? What? From here. But look at the formula. The most torque. Why? Because always the force will be applied at what angle with respect to the radius? 90 degrees. So we get the maximum torque. You understand? We will get the maximum torque because no matter what you hold this, it's a round object, will be at 90 degrees. We get the maximum torque, and you have to do just like this. But if it was at an angle, you have to, you know. So this is the idea, the torque. Okay, this is just how to get the torque on a round object. Any question? Good, we know what is torque. So torque, what will be analogous in linear motion? It's not the same, two different things. But to what? Torque, no. To F. It's analogous, not the same thing, but it's analogous to F. So torque is analogous to F in linear motion. It's a vector, work is a scalar. Good. Now, we know what is torque. Now we know, we go, another thing important to know. So now I explain what is torque. It's the ability to rotate the body, and it's based on three factors. The distance to the axis of rotation, the force, and the angle. If the angle is 90 degrees, we get the maximum torque. If they are parallel, what will happen? No torque. Everybody can see that if I apply the force like this, look, I never will rotate the body. I am acting parallel to the hinge. Can you rotate? No. Why? If you have a sine of 0 degree parallel, what will be the torque? 0. No torque. This is the definition of torque. But we learned in linear motion also an important thing that it was called mass. A mass was the measure of inertia. Now we will learn an analogous value here, which will be related to m, but it's not m. In rotation, we have other factors other than m that influence the motion. For example, let's say that we have two objects. Don't have here, but let's say that I have two objects, let's say with the same mass, like this. Let's say that they have the same mass. They will rotate the same way. So you can see that if I put this here, look, they are competing. Oh. Okay. Do they rotate? So this is because we have this here. If this changed the whole moment of inertia. That is what is the mass related to. But if I put this and a hollow one with the same mass, you think that they will move the same way? No. Put a bowling ball and a ball that is empty but has the same mass. Will have the same type of rotation? No. So, in addition to the mass, I mean the ability to rotate or the tendency to resist any rotational motion will depends also on the distribution of the mass. Besides the mass itself, the distribution that is the mass here along the radius. Those two things will be called moment of inertia. But let me just explain that through here, through the Newton law. Let's say that I apply the force to here. So sigma F, imagine that